So, whenever you have logs on both sides, they have the same base. So if you raise both sides to the powers of 10, the logs cancel on both sides. So you can just drop the logs. So we're going to have 10 minus 4x equals 10 minus 3x. And so, Ethan, what would we do next to solve that?
I put the 4 to the other side of 4x.
Okay. Perfect. That's what I would do too. Avoid those negatives.
And then I subtracted 10.
Good. And what do you get for your answer?
So it'd be 1x.
What is 10 minus 10?
Yeah,
0. So you'll get 0. Now, we cannot take logs of 0. But if I plug 0 back in up here, do I get a 0? 10 minus 4 times 0 is 10, right? And 10 minus 3 times 0, also 10. So it's fine. 0 can be your answer. You just can't take log of 0 when you plug something back in.
So you would write x equals 0.
Right. X equals 0 is your answer for this. Oh, let's do 6 because it's a horrible problem. I do not like the way that they have formatted number 6 because it looks like this says 2 log base 7 minus 2r equals 0. But it actually is of negative 2r. There should really be parentheses around that to clarify that it is log base 7 of negative 2r. So I don't like the way that problem is formatted because it looks weird. But the parentheses will help us a little bit here. So, first off, one thing we got to be really careful of, if you only have one log, do not drop the logs here. You have to have logs on both sides with everything contained inside of it like we did on the last problem. So we cannot drop the logarithm. We've got to solve this. So let's see. You got a couple options. You could pull this back in as an exponent, but I would not on this because the easiest thing to do with that 2, it's 2 times this log. Just divide it by 2. Divide it off. So you got log base 7 of negative 2r equals 0. And so, Mia, now we need to get rid of that log. How do we get rid of the log? We can't just drop it like we did on the last problem because it's not on both sides. So what's the opposite of that log base 7? Okay, who can help her out? What is it, Matthew?
Would you put it to the exponent of 7 and then do the other side to get 1?
Perfect. So the base raised to that exponent is the opposite of your log. So if you need to get rid of a log that's just on one side, you're just going to raise it to that power. So that will get rid of the log on this side, so we'll have negative 2r. And then over here, we'll have 7 to the 0 power, which is 1. And your quiz tomorrow will be calculator active, but you will be using the handheld calculators. So know that going into it, you won't have Desmos because that makes me give you that. Although I think I may have found a way around that, which we're going to try because we got some graphing stuff coming up. So I've made a quiz that I think I can give it in Canvas with Desmos embedded, but I'm not going to try it on this one. We're just going to use handheld calculators here. All right, and then our last step here, just divide by -2. So R equals -1/2. You do always want to kind of check your answers, because see, I'm getting a negative answer here, which seems wrong. But if I plug -1/2 back in up here, -2 times -1/2 gives me +1, which is positive, so it's okay. In fact, I don't think you're going to get a no solution on this worksheet for the quiz tomorrow, but I just want you to know that can happen sometimes. Some worksheets we do. Yeah. Questions on 6? All right, let's see. Let's get down to number 11. So for 11, we've got log base 12 of v squared plus 35 equals log base 12 of -12v minus 1. All right, so, Cade, what would we do first on this problem? Okay, so same base, everything's on the inside of the log, so you can just drop the logarithms here. So you got v squared plus 35 equals -12v minus 1. Oh, we got a square. We did one of these yesterday, but some of you had a little bit of a frightened look on your face whenever we did it. Whenever we've got a square, what do we need to do to solve this? What was that? Set it equal to 0. Good. So everything needs to be moved to one side, right? So I would move the 12v over here. I'd add this 1 right here to move it over. So I got v squared plus 12v plus 36 equals 0. So when you have a square, you need to move everything to one side. You're probably going to have to factor to do these. So we're going to factor this one. How does this one factor? Yeah, 9 and 3 will be 27. That almost seems like it should work. What is it? 6 and 6. So plus 6 plus 6 here. That'll work because 6 and 6 will give us 12. 6 times 6 is 36. And then once we factored, either one of these could be 0, so we just set it equal to 0 because it's the same one here. I'm just going to do it one time. So if you subtract that 6, v is going to equal -6. And it seems a little wrong that it's negative, but if you plug it in here, v squared, you're squaring that negative, so it becomes positive. Right here, you got -12 times -6, which becomes positive, so it's okay. You have a negative answer here. Yes?
Could you do number 9? Because I'm looking at it.
Okay, so for 9, we've got log of, and I wish they would put parentheses, that m is the only thing that is inside of the parentheses there. Especially when we put that negative, I wish they'd put parentheses, but they didn't. So we're dealing with this. We cannot deal with that log yet because this 2 over here is not associated with that log. So the first thing we want to do on that is we need to get rid of that 2. What can we do to get rid of that 2? We're just going to subtract it off. So if you have stuff outside of your logarithm that you need to get rid of, deal with that first before you start messing with the log. So we got log of negative m equals 2. What do we do after that, Matthew? Good. 10 to the power on both sides, which is going to cancel your log. So you got negative m equals 10 squared, which is 100. And then what's your last step on that, Matthew? Good. And that's just going to give us m equals negative 100. Yes.
So I was looking at 12,
Yes.
and so I got it factored now,
Mm-hmm.
but it's 2, it was like, it's x plus 7 and then x plus 4. What do I do after that?
Okay, so whenever you get to x plus 7 and x plus 4, you're just going to set each one of those equal to 0. And so you'll get x equals negative 7 and x equals negative 4. So that one actually has 2 answers. Yeah, so it's okay to have 2 answers on those. All right, let's skip over to the back and let's do number 15. All right, so 15 is where what we did on Monday and what we did yesterday start to come together. Okay, so we haven't done one quite like this yet, but we know all the pieces we need to know. So I'm going to do this one incorrectly at first, so don't write it down. This is wrong. All right, so I'm going to do it in red. Don't write it down. So the base on these logarithms are 10, right? So what students want to do sometimes is raise everything to the 10th power. And then cancel out your logs. X plus 8 equals 2. This is not correct. Okay? Because what we have to do, if we do that, what we have to do if we do it that way, lock it in place this time, is we have to do 2 to the power once on this side and 10 to the power and 10 to the power right here, which you can't do anything with because these two have that plus sign in between. So if you see something where you've got more than one log, we need to use our property of logs to condense them, and then we can solve the equation. Now, the only time that's not the case is if it's where there's just one log on each side and you can just drop the logs, right? But here we've got to put these logs together. So if I've got log x plus log 8, then I can combine them using multiplication. So that is log of 8x equals 2. Then I have something that looks like something we've done before. So let's see. Manuel, what would we do to solve this? All right. What is our base on that logarithm? What number? 10, right? It's not written, but there's a 10 there. So to get rid of a log base 10, we have to do 10 to that power. Right? And so that will cancel our log base 10. Which leaves us with 8x equals 10 squared, which is 100. So the opposite of a log is raising it to that same power that you have for your base. And so, Manuel, what's our last thing that we would do? Divide by 8, which does not go evenly, but will reduce into, so we divide those by 4, so 25 over 2.
Could your answer be 12.5?
Yes, that should be fine. And actually, probably, your quiz tomorrow is on Canvas, so I probably have it set for the decimal instead of the fraction on those, because when you guys go to type it in fractions in the Canvas, it just doesn't work. So it'll be calculator active, so you'll just give me the decimal. Okay, so for number 8, what would you do first, Zach? Okay, and how do we do that? Good. You could pull it in as an exponent, but that's going to make things way too complicated. So divide it off. Log base 5 of 7x equals negative 1. All right. What would we do next? Okay. 5 raised to that power, right? All right, and that cancels out our log. So we've got 7x equals 5 to the negative 1. All right, so negative exponents. If I have 5 to the negative 1, there's no fraction right now, which means that's in the top of the fraction. So when I teach negative exponents, I teach students that they're like bad children. What do you do with bad children? You lock them in the basement. It will fix them and make them good children, which will give them a positive exponent. So you will have 1/5. So negative exponents are going to move to the other side of the fraction bar. Sometimes you might get something like this. Like just say you had this 3 to the negative 2. In this case, you live in a house without a basement. So if you have a bad child, you have to lock them in the attic. So you move them up to the top, which is going to fix their behavior also. So there's some good child rearing advice for you that will help you. So this is really 7x equals 1 over 5. I don't lock my children in the basement. Although sometimes I might would like to, but I don't. I feel like definitely lights off. Yeah. Even better if you have like a scary wood stove or something in the basement too. My parents' house, they have a scary wood stove. They didn't lock me in the basement either. Just in case you're wondering there. Alright, so last step on this one, we're going to divide by 7. I would prefer doing this. Divide by 7 is same as multiplying by 1/7. I like that better here, so that you can go ahead and do these fractions. So you get 1 over 35 for that. Which again, tomorrow you can type in the decimal for that. My answer key is in fractions here. Questions? Yes.
How would you get 1 over 35 again?
So whenever you're doing this, what I prefer to do, so dividing by 7 is the same as multiplying by 1 over 7. So I just multiplied both sides by 1 over 7. I think that's the quickest way to do it since you know you got a fraction over here. And then to do fractions, you just multiply straight across 1 over 35. Or, if that messes with your mind a little bit and you don't like it, you're really just dividing both sides by 7. So when you're doing 1/5 divided by, that's like a 7 over 1. How do we divide fractions? flip and multiply. I always say dividing fractions is as easy as pi. Flip the second and multiply. So you got 1/7 here, and then you would get that same thing. But I'd go straight to the flip and multiply whenever I have a fraction, just because that helps me think about it a little bit more. All right, any questions there? All right, let's do a couple more of these other ones where we got to combine. So let's look at number, let's do 20. So we've got log base 9 of x plus 6 minus log base 9 of x equals log base 9 of 2. Alright, I'm going to do it wrong again. Okay, this is what a lot of students do right here. X plus 6 minus x equals 2. Just drop the logs. Yeah, you can't do it because of this minus sign right here. You cannot drop the logs. So you can only drop the logs if you got one log over here on the left and one log over here on the right. Right? And nothing else outside of the logs. So you cannot drop the logs here. You have to combine your logarithms first. Then you can drop the logs. So what we're going to do here is over here on that left-hand side, we have subtraction, which if we put it together, what do we use for that? Division. So we're going to have log base 9 of x plus 6 over x equals log base 9 of 2. Now, I only have one logarithm on both sides. So I could do 9 to the power right here on both sides. It's going to cancel both of those logs. And so I've got x plus 6 over x equals 2. Alright, let's see how good you guys are. What do we do, Bo? Good. You cannot solve for a variable when it's in the denominator. So you got to get it out of that denominator, even if it makes it more complicated to begin with, all right? So we're going to multiply by x here, which cancels the x in top and bottom, and multiply by x here. So we got x plus 6 equals 2x. All right, just keep going with that, Bo. What will we get? What will we do next? Good. And so we'll get 6 equals just x, so there's our answer. We get 6. All right, let's do... All right, we're going to do 24, and we're going to do it a couple ways. We're going to do it the answer key way and the quiz way. So for 24, we've got natural log of negative 3x minus 1 minus natural log of 7 equals 2. So I'm going to do this two ways. On the quiz tomorrow, you can give me decimal answers. So we can use our calculator and get decimal answers. So I'm going to show you how to do that in a second. On my answer key on this, they don't give decimal answers. And sometimes you'll see it like this on like ACT problems and stuff as well. So I'm going to show you how to do it both ways. The first way is going to give you a really ugly answer that I don't really like, but sometimes you might see it, so I want to expose you to this just in case. So we got natural logs, but we've got more than one on one side, so we got to combine those first. So Wesley, what's that going to look like if we put those together? Yes. Perfect. So we got natural log of negative 3x minus 1 over 7 equals 2. Can we drop logs? No, because there's only one on one side. So how do we get rid of that natural log? E to the power. That's the opposite of our natural log, which means we've also got to do that over here. Okay, so I've got negative 3x minus 1 over 7 equals E squared. Now, I'm going to do this without a calculator way. That is what the answer key does here. And then we'll also go back and look at it the calculator way. So the first step's the same no matter which one you're looking at. So remember, you're solving for this x right here. E is actually a number, right? So we're trying to get that x by itself. So Wesley, what would we do next? Perfect, because we can't have that denominator. It's messing us up, right? So we're just going to multiply by 7 on both sides. So we got negative 3x minus 1 equals 7e squared. Okay, again, still trying to solve for that x. Don't let it mess you up that you got this weird 7e squared over here. What would you do next? Perfect. So I got negative 3x equals 7e squared plus 1. And what would your last step be? Perfect. So the answer key is going to give the answer like this. It actually gives you negative 7e squared minus 1 over negative 3, not negative 3, positive 3. So it basically puts that negative up in the numerator instead of the denominator there. You don't necessarily have to do that. You could just leave it. Oh, eraser. You could just leave it like this answer right here is fine. But the answer key will be on Canvas, so I want you to know what's going on there. So this is what they're going to give you for the answer key. So it looks crazy. This is a horrible answer that I don't really like to see, right? Because it's got all that weird stuff. So the answer key on this is your exact answer, so it just leaves it like this. Now, tomorrow on your quiz, if I try to have all of you guys typing this answer into Canvas, there's no way you're going to all get the right answer because Canvas can't recognize that. So tomorrow we're going to use decimals on the quiz. So let's go back and look at this with decimals. One thing you could do, if you solve it the way that I just solved it, let's get the calculator. One thing you could do is you could just take this answer, make sure you put parentheses around the numerator, negative 7e to the second minus 1 divided by 3. You could just type this answer in and get that it's negative 17.574. So that's one way you could do it. Or the way I would probably do it is I would go back to this step that we had right here. Negative 3x minus 1 over 7 equals e squared. I would go ahead and with my calculator change that e squared to a decimal. So 7.389. So the steps are still the same. You're just going ahead and using decimals. So you multiply by 7 on both sides. Negative 3x minus 1 equals 51.723. You would add 1, which would give you 52.723. And then you would divide by negative 3. So x would equal, let's make sure we're getting the same thing. negative 17.574. And everything on tomorrow's quiz, when you type in the decimal, make sure you got at least 3 decimal places for me. So it'll count it right. So tomorrow you would type that in as your answer. Okay, I think that covers pretty much all the types of problems you're going to see. So I'm going to quit working these together and let you guys work right now. We still got about 20 minutes left in class, so hopefully you'll be able to get a lot of this done before you go. The rest of the worksheet, all the ones we have not done, will be your homework for tonight. Okay? Any questions on anything? As you're working, if you're getting stuck on something, let me know. We can't congregate, but if you are talking to ask people around you something, that's fine. I don't mind that. I look forward to the day where I can put you back in groups and you can move and like sit next to each other and breathe each other's air without worrying about it and all of that. But that's just not today.